66 million years ago, the worst day in the history of life on Earth started like any other morning. Warm, quiet, ordinary. Because nobody on this planet knew that a rock the size of Mount Everest was already falling toward it at 12 miles per second. 12 miles every single second. In the next 60 minutes, 3/4 of every species alive would be sentenced to death, minute by minute. This is exactly how it happened. And stay to the end, because the same sky that did this is still loaded. First, let's set the scene, because the world that morning was glorious. Dinosaurs had owned this planet for over 160 million years. To put that in perspective, the gap between you and Tyrannosaurus rex is shorter than the gap between Tyrannosaurus rex and Stegosaurus. They had survived everything the planet could throw at them. Volcanoes, shifting continents, changing seas. They were not weak, they were not failing, they were thriving. And none of it would matter. Meanwhile, out in the dark, the killer had been on its way for a very long time. It was a chunk of ancient debris about 6 miles across, the size of Mount Everest if Everest were flying. Rocks like this are leftovers from the solar system's construction site, 4.5 billion years old. Somewhere out there, long ago, a collision or a gravitational nudge changed its path by a whisker. That whisker, multiplied over millions of miles, pointed it at one small blue dot. There was no warning system, no telescope watching, no one to see it coming. The most consequential object in Earth's history arrived completely unannounced. Minute zero was seconds away. Minute zero. The sky over the Yucatan Peninsula tears open. The asteroid crosses the entire atmosphere in about 3 seconds. It hits the shallow sea moving so fast that for an instant, it punches a hole in the air itself, a vacuum tunnel stretching back towards space. The impact releases the energy of billions of Hiroshima bombs at once. The rock, the sea, and the bedrock beneath it don't shatter. They simply turn to vapor. Rock behaves like liquid. The Earth rings like a struck bell. Anything within 600 miles is already gone. It carves a crater 110 miles wide and 12 miles deep into the crust. The flash was so violent that if anyone had been standing on the moon that day, they would have seen our planet visibly spark, a pinprick of white fire on the blue marble. Minute 1, and the whole planet is about to find out what just happened. The blast hurls trillions of tons of molten rock straight up, much of it clean out of the atmosphere. And what goes up must come down. For the next hour, that debris re-enters all around the globe as a worldwide rain of white-hot meteors. All that falling fire heats the sky itself. For an hour, in many places, the air above the forests glows like the inside of an oven set to broil. Trees don't catch fire from flames, they ignite from the sky. On the worst day ever, even the sky burned. Meanwhile, the ground itself is moving. The impact triggers the strongest earthquake in Earth's history, perhaps magnitude 11. Thousands of miles away, the land rolls like the open ocean. And then the ocean answers. Minute 30, the wave. Near the crater, the sea rebounds in a wave that may have stood taller than a skyscraper, possibly the largest tsunami this planet has ever produced. It sweeps the Gulf Coast clean and pushes hundreds of miles inland. Here's the detail that still gives scientists chills. In North Dakota, 2,000 miles from the crater, the shaking sloshed rivers backward and buried fish alive, their gills still full of impact debris. We found them, 66 million years later. A snapshot of the worst hour on Earth, frozen in rock. But the first day wasn't the killer. The killer was what happened to the sky afterward. Soot from the burning forests and dust from the vaporized rock spread around the entire globe and switched off the sun. Not for days. For years, the surface got barely more light than a moonlit night. No sunlight means no photosynthesis. plants died. Then the plant eaters starved. Then the meat eaters starved. The entire food web collapsing link by link in the dark, in the cold. Summer didn't come back for years. And the sky had one more poison to deliver. The vaporized seafloor was rich in sulfur, which came back down around the world as years of acid rain, souring lakes, and the surface of the seas. When the sky finally cleared, the planet took roll call. 3 out of every 4 species didn't answer. The die-off followed one brutal rule: size. Almost nothing heavier than a house cat made it through. Big bodies need big meals, and for years there were none. The tyrants who had ruled for 160 million years, gone in what geology considers an instant. Not because they were failures, because no giant could survive a world with the lights turned off. The age of giants ended in the dark. The oceans fared no better. When the sunlight died, the plankton died, and with it, the food chain that fed everything from ammonites to the great marine reptiles. The seas went quiet too. But extinction has a flip side, because the day the giants died was also day 1. The survivors shared a profile: small, warm-blooded, able to burrow, able to eat scraps, seeds, insects, carrion. Our ancestors were among them, shrew-sized, trembling, unimpressive, and suddenly holding the keys to an empty planet. And one dinosaur lineage made it too: the small, feathered ones. You know them. They're outside your window right now. Every bird on Earth is a living, singing dinosaur. The dinosaurs never left. They just got smaller and learned to sing. The other winners? Crocodiles and turtles, cold-blooded, patient, happy to eat carrion in the mud. Slow metabolism turned out to be a superpower when the menu ran out. Now, how can we possibly know all this? Because the crime scene left evidence everywhere. In 1980, a father and son team noticed a thin clay layer in the rocks, laid down exactly when the dinosaurs vanished. It was loaded with iridium, a metal rare on Earth and common in asteroids. The same layer shows up on every continent. The idea was ridiculed until 1991 when the crater itself was found, a 110-mile ring buried under the Yucatan Peninsula, its age matching the clay layer to the moment. Case closed. You can even trace the crater's rim from the ground. A perfect arc of water-filled sinkholes curves across the Yucatan, the crater's edge showing through 66 million years later. And scattered through that same layer all over the world sit tiny beads of glass, droplets of rock that were vaporized, flung into space, and froze into glass as they rained back down. The Earth remembers, you just have to know where to look. Which brings us to the question you've been waiting for. Could it happen again? Yes. But this time there's a difference. In 2022, humanity ran a test. We slammed a spacecraft called DART into an asteroid on purpose and measurably changed its orbit. It was the first time any species on Earth altered the path of a celestial body. Meanwhile, telescopes now track nearly every giant near-Earth asteroid, and none of the big ones are on a collision course. The watch is real, it's funded, and it works. The dinosaurs didn't have a space program, we do. So tomorrow morning, when you hear birds singing outside, remember what that sound is? It's the survivors' descendants singing about the day the sky fell and life refused to end. If the rock were coming next year, do you think we'd stop it? Tell me below. And subscribe. The universe writes the wildest stories, and we read them together.